You know that feeling, right? You spend all this time crafting what seems like the perfect, crystal clear instruction for an AI, only to watch the model completely ignore it? It's probably one of the biggest frustrations out there. But what if the model isn't being disobedient? What if it's just following a different set of rules that you can't see? And that gets to the core idea we're going to decode here. Models don't really ignore instructions. What they do is enforce a hidden hierarchy. They're constantly weighing your request against a whole series of other, often invisible instructions. And, well, in that conflict, your prompt doesn't always come out on top. So let's start with that all too familiar moment. You've been incredibly specific. You've given all the right context. You've laid out the constraints perfectly. And the output is something else entirely. Thing is, this failure isn't a bug. It's actually a feature of how these massive, complex systems are structured. Now here's where it gets really interesting. This whole idea of a hidden hierarchy, it isn't some weird quirk unique to AI. It's a fundamental pattern of control that exists in pretty much every complex system humans have ever designed. It's a world where priority, not just your intent, determines what actually happens. Just think about basic software engineering. If you try to do something, say delete a critical system file, your input gets denied. Why? Because a core, system-level security process has a higher priority than your user-level command. It's a simple, non-negotiable hierarchy. Or look at the legal world. A local city ordinance can't just override a nation's constitution. The Constitution is the highest level instruction in the whole system. Every other law has to be interpreted in its shadow. When there's a conflict, we all know which one wins, the higher authority, every time. And that brings us right back to AI. The exact same principle is at play. There are instructions that have been baked into the model at a deep system and developer level, and those instructions simply carry more weight than the prompt you, the user, just typed in. So when your instruction seems to get ignored, what's really happening is that it just lost a battle for priority. Okay, so let's get into the mechanics of this. How does this hierarchy actually work when the model is generating a response? It's not as simple as one rule just canceling out another. It's actually a much more dynamic and, frankly, statistical process. The easiest way to picture it is as an instruction stack. At the very top, with the highest authority, you've got these deep system-level instructions, things like be helpful and harmless. Then, a layer below that, you might have developer-level constraints that define a specific persona or an output format. And way down at the bottom, with the lowest authority, is your prompt. In a head-to-head conflict, your instruction is the most likely to get overwritten. So what happens when two instructions are in direct competition? Like, say you ask the model to be both concise and to provide a detailed explanation. The model doesn't sit there and make a logical choice. Instead, it resolves that conflict based on probability. It literally calculates which path is statistically more likely given all the weighted signals it's juggling. And these are the factors that tip those probabilistic scales. A super-specific instruction carries way more weight than a vague one. An instruction you repeat over and over gains strength. Even where you place an instruction inside your prompt can give it more or less priority. It's like this constant silent auction for influence happening inside the model. And this just nails the point home. Clear, atomic, almost mathematical constraints will dominate vague, complex requests pretty much every time. Why? Because an instruction like reduce to 3 bullet points under 50 words each massively reduces the room for interpretation. It's a structurally dominant command. Meanwhile, make this better is just an ambiguous wish. You know, misunderstanding this whole system isn't just a simple technical error. It comes with a very real cost. Professionals who don't quite get this dynamic, they end up paying what you could call the ambiguity tax. This tax is paid in the currency of wasted hours. Hours spent trying to fix an output that was actually a perfect response to a flawed set of instructions. It's paid when developers go chasing phantom model errors, or when analysts accept a watered-down, shallow summary because their competing instructions just neutralized each other. And that's the key takeaway here. A bad output is almost never a single, sudden event. It's the final result of a whole series of misaligned, competing, or ambiguous instructions that have been piling up throughout the entire stack, from the system level all the way down to the last word in your prompt. Okay, so if that's the system we're working with, how do expert operators get such consistent, high-leverage results? Well, they don't just write prompts. They think about it in a totally different way. They actually design their instructions to win that probabilistic battle for priority from the start. They're practicing something called constraint dominance. Their goal isn't just to say what they want. It's to frame instructions with such clarity, such structural integrity, that they become the highest weighted signal in the stack by a long shot. They're not just asking for an output, they're designing for dominance. So this brings us to the final piece. Now that you have this framework, it's time to kind of audit your own approach. And we can do that with a few quiet but maybe slightly confronting questions. Go back and look at your last frustrating output. Looking at it now, can you dissect your prompt and figure out which of your instructions likely won that priority auction? Was it the clearest one? Was it the last one you mentioned? Or was it the one that just happened to align best with the model's core training data? Think about what you're asking. Are you asking for wild creativity but also demanding strict adherence to a rigid format? Are you asking for a deeply detailed summary that also needs to be extremely brief? You have to look for these silent conflicts in your own prompts because the model sees them and it's being forced to make a probabilistic choice between them. And finally, this is probably the biggest mental shift to make. Are you consciously designing a set of instructions where your most critical constraint is also the most structurally powerful? Or are you just listing a bunch of requests and hoping the model magically figures out which one you really meant? The answer to that question is the difference between commanding an output and just getting a response.